Welcome to javapassion.com Java programming webinar. So today's topic is collections framework. So we are going to cover what is and why collections, and then we are going to go into Java interfaces and implementation classes that make up Java collection framework. And then we'll cover the concept of natural ordering, and then at the end we are going to cover collections utility class. So what is a collection, and what is and why we want to use Java collection framework? You can think of collection object as a container of other objects. In fact, you can think of it as bag of objects. So collection objects are used for manipulation or storing or retrieving and sending aggregate data, meaning bag of objects between methods. So collection represent typically real life data items. For example, poker hand can be represented with a collection of cards. Mail folder can be represented with a collection of letters. And telephone directory is a map of names and phone numbers. So what is Java Collection Framework? Java Collection Framework provides unified architecture for representing and manipulating collections. From a Java developer standpoint, it is basically a set of Java interfaces and implementation classes. So benefits of usage of Java Collection Framework. So in many applications, you are going to have to deal with manipulation, storing, and retrieval of this bag of objects. So you need something like a collection, semantics. So that's the reason Java Collection, JDK, comes with a Java Collection Framework. So you don't have to create your own Java Collection Framework yourself because it's provided by the JDK. And the implementation that comes with the JDK is highly optimized, so it should provide pretty good programming speed and quality. And it allows interoperability among unrelated APIs. So as we will see in a few minutes, Java Collection Framework is made of interfaces and their implementation. So interfaces are used as types, common language, common types by the APIs. So it provides interoperability and fosters software reuse. So you can certainly implement your own implementation of Java interfaces if you want to, but by using some common language, common types of these interfaces, basically implementations could be actually reusable. So let's spend the rest of the presentation going into actual Java interface and implementation classes. So collection interfaces are basically abstract data types. And just like any other Java interface, it provides polymorphic behavior. So this slide shows interfaces on the left and their implementations on the right. So important interfaces we are going to cover extensively include set, list, and map, and these are then implementation classes. So let's go into core collection interfaces first. So this is the core collection interfaces hierarchy. So on the top we have collection and map interface, and collection interface has a child interface of set, list, and queue. And set subinterface also has a child interface of sorted set, and map also has a child interface of sorted map. So these collection interfaces are the foundation of the Java Collection Framework. Basically, as you have seen, it forms inheritance hierarchy among themselves. So let's look into the top Java interface, top collection Java interface. So we are going to go into a bit more detail of this interface type. So collection Java interface, it is the root of collection hierarchy, as you have seen, which means every collection object is a type of collection interface. So if you have to pass around the most general collection type, then you are going to use collection as interface type. By the way, the actual implementation classes that are provided by the JDK doesn't provide direct implementation of collection Java interface. Instead, implementation classes implement sub-interfaces of collection Java interface. For example, set and list. So these are two main Java interface types that we are going to look into in detail. So this is a collection interface, the code. So it does provide basic operations such as getting a size of the collection, meaning how many elements it contains, whether it is empty or not, whether it contains a particular object or not, particular element or not. The most frequently used methods of collection interface are these two methods. You can add an element and you can remove an element. You can also create an iterator object from a collection object. You can also perform bulk operations, and you can also convert your collection object into array object. So this is an example of collection interface as a type. So we created array list object instance and then assign it into collection type. And then we can use any method of collection interface type. For example, we can call add method, or we can call isEmpty method. Now, depending on what concrete object instance is pointing to, the behavior of add method could be different, and that's the polymorphic behavior that we just talked about a few minutes ago. Okay, so we are going to go over these methods of collection interface in a bit more detail. So let's take a look at add method and remove method. So add method adds a specific element to the collection object. And again, depending on what object instance it is pointing to, a polymorphic behavior will be used. So if you have if the collection interface type is pointing to a set object, then there is no duplication rule be applied. And the add method returns true if the collection changed as a result of the call, meaning if adding an item, adding an element to a collection is successful. Remove is removing an element from the collection object. Again, it returns true if an element was removed as a result of this call. You can also perform traversing of collection object. There are two different schemes that you can use to traverse a collection object. You can use for each loop, or you can use iterator class. So this is pretty straightforward. So you can say for each object in the collection object, I'm going to take it as object type O, and then I can do anything I want inside this for loop. Iterator is an object that enables you to traverse through a collection and remove elements from the collection selectively if desired. So let's see iterator interface. So it does support three methods: has next and remove. So remove is rarely used. So has next method returns true if iteration has more elements. So if there are still some elements that have not been iterated, then it will return true. The next method returns the next element in the iteration. Now, remove method removes the element that was just returned from the next method from the underlying collection object. So let's see the example code. So let's say we have array list collection object. We created iterator object by calling iterator method of collection interface. And then we can call hasNext method. And as long as there is a next element, as long as there is actually some element in the iteration, it will return true. And then you can call next method to get it. And then if you want, you can call remove to remove it from the collection object. If you don't have this one, then it's not going to remove that element from the collection object. So if you are running these things again, if you have suppose if you don't have these 4 lines of removal of an element, and if you rerun this while loop, then it will just display the same set of elements from the collection object. So collection interface also supports bulk operations. So contains all, add all, remove all, retain all, or clear. So most of these bulk operation methods are somewhat obvious. The only thing that might be a little bit confusing is retain all. So it retains only those elements in the target collection that are also contained in the specified collection C. Okay, so if the collection C contains ABC, then the target collection retain only those ABC elements after this method is invoked. Array operation. So you can create array object by calling toArray method of your collection object. So toArray, in general, you should be able to use collection object without actually converting into array object. But there are some cases, if your application are in fact designed long time ago, that is dependent upon on array. I mean, if you have an old method that you've written that receive an argument in the form of array object, then you can actually convert your collection object to array object and pass it to that method. So this is how you can create array of objects. So basically from your collection object, you call toArray method, and then you get array of objects whose types are object. Okay, so let's move on to set interface and implementation classes of set interface. So set interface represents a collection that cannot contain duplicate elements. So these examples, cards comprising a poker hand, you cannot have duplicate cards. A student schedule cannot have a duplicate courses. A machine cannot have a duplicate processes. So these are the examples that you can use with a set interface and their implementations. So it is implementation classes that actually provides the restriction that duplicate elements are prohibited. Now the equals and hash code methods of set interface have a stronger contract in their behavior, actually different behavior from the default behavior of these two methods of object. So in the case of set, if two set the two set instances are considered equal if they contain same element. Okay, so let me actually run the sample application. I just created set equals here. Suppose I have code. So I have hash set 1, hash set 2, and here I'm adding 1, 2, 3, 2. So because 2 is duplicate here, it will just have 1, 2, 3, and then I created the second hash set instance. And here I added 1, 2, 3, and 3. Again, the last 3, this one should be disregarded because duplication is not allowed. So both hash set 1 and hash set 2 contains 1, 2, 3. So now, I can compare. I can use either equals or I can use 2 equal signs. So this is going to return false, and this is going to return true because the semantical behavior of equals of set object, like a hash set object, returns true if they contain the same element. Okay, so if I just run this code, so here this is obviously false because they are actually pointing to different object instances. However, equals method returns true. Okay, moving forward. So there are 3 implementation classes of set interface: hash set and tree set and linked hash set. Okay. So let's look into each of these implementation classes in a bit more detail. So hash set class is much faster than tree set but offers no ordering guarantee. So hash set order is not guaranteed, meaning it's a random order. But it's faster because it's using hash. And it offers a constant time performance because it's using, again, hash. So for this basic set of operation, add, remove, contains, or size, it will be performed in constant time performance based. And it is mostly commonly used set implementation. In terms of capacity of hash set, if you choose initial capacity that is too high, then you are actually wasting both the space and time. If initial capacity is, however, too low, then because it's going to increment the size, you are actually wasting time by frequently increasing the size of it. So it's important to create hash set with reasonably expected capacity, meaning capacity that is expected to be used. Okay, tree set. Tree set implements sorted set. So we're going to take a look at sorted set interface later on, but basically tree set has ordering as opposed to hash set, which doesn't have ordering. So you want to use a tree set when you have ordering behavior. So when you have a value ordered, iteration is important. I mean that if there's something that you need in your application, then you can use tree set. So this is an example code of tree set. Suppose I created a tree set object and I added 1, 2, 3, 4, and 3 again. So this will be disregarded because this is a duplication. Now when you display this tree set object, it will display things in the order of these objects. These objects are string objects, and string objects are natural ordered through alphabetical order. Natural ordering is alphabetical order for string class. So it will display 1, 2, 3. I'm sorry, it's going to be 4, 1, 3, and 2 because F is alphabetically before O, and this one 3 and 2. So this is actually alphabetically before this 2. And we are going to talk about the concept of natural ordering in a few minutes. Linked hash set is implemented as a hash table with a linked list running through it. So it's a combination of hash and linked. So it provides insertion ordered iteration. So it basically lists recently inserted to most recently and runs nearly as fast as hash set. So linked hash set will provide insertion based ordering. So it spares clients from unspecified, generally chaotic ordering provided by hash set, meaning it doesn't have any order guarantee without incurring increased costs associated with the tree set. So tree set provides the ordering, but it actually has a bit more increased cost in terms of performance. But so in that case, you can use linked hash set. Okay, so this is an example. As I said before, is going to provide an ordering based on insertion. So we are ordering, we created a linked hash set. Now we are adding integer values, integer objects to this set collection object, and 2, 1, 3, 3. So this is a duplication. So we'll have 3 elements in this linked hash set object. Now when you display it, you're going to have the elements to be displayed in insertion order. So you will see 2, 1, 3. And when you created the iterator object, and the order will be the same. Okay, so this is an example code in which we are using 3 different set implementation classes. The first one, we are using hash set. Second, we are using tree set. And third, we are using linked hash set. So as we talked about, hash set does not guarantee any order. Tree set provides order based on natural ordering of the object type. So in this case, it could be values because we are using integer value in this particular example. And linked hash set provides order according to insertion. So here we have my own utility class, and then you also check the duplication, and then the arguments is basically a set of the values. So here, this is just utility class that just kind of check whether it has a duplication or not. And so by using just a set implementation, we can check whether it has a duplication or not. So when you try to add particular element to the collection, if it returns false, that means that is duplication. So suppose we have added these numbers 2, 3, 4, 1, 2. Okay, so and then we display. Then we create a set object. So going back to this code, okay, so these arguments is 2, 1, 4, 1, 2 or something like that, and then we created a hash set, and then we display that set object, and then we create it from the same arguments, and then we basically displaying it again. And so basically, depending on what set implementation you're using, order will be different. So the first one, hash set, there is no order guarantee, so it is random. For tree set, it is value-based ordering. Again, it's a natural ordering on integer class. That's value-based. And then linked hash list is insertion-based ordering. So you can see 2, 3, 4, 1. Okay, synchronize access to set objects. So hash set, tree set, and linked hash set, they are not synchronized by default. So if you have multiple threads that are modifying this set object, hash set, tree set, or linked hash set object, you might want to have some synchronization functionality wrapped around it, either by using some object, or you can use the synchronize block. But if you don't have those kind of features, then you can actually wrap it using a synchronized set method of collection utility class. So once you call collections.synchronize the set method with hash set object, and then you got the set object, at that point this object is synchronized, meaning multiple method can actually use that set object, and the access will be synchronized. Okay, so concept of natural ordering. So before we talk about natural ordering, let's talk about the sorted set interface. It is a set that maintains its elements in order, and the tree set, as we talked about, implements not only set interface but also sorted set interface. Actually, sorted set interface is the child interface of set. So in this case, order is defined through what is called natural ordering by default, or you can specify your own custom comparator, the class. So you can, several additional operations are provided in this sorted set interface. For example, you can find out what is a comparator, class that you're using, and what is, you can also call first and last method. All right, so concept of natural ordering. What is a natural ordering? So a class is said to have a natural ordering if it has implemented Java-lang compatible interface. Pretty straightforward concept. Okay, so let me repeat one more time. A class is said to have a natural ordering if it has implemented compatible interface. So compatible interface has a compare to method, and that compare to method will provide comparison logic. Now, most of the JDK basic classes, such as the string, date, and integer, already implemented Java-lang compatible interface, which means they have natural ordering. So in the case of string, the logic of comparison is based on alphabetic order. In terms of date elements, natural order is based on chronological order. Okay, so compatible, the compare to implementation is based on chronological order, and for integer is based on number, the value. So if you actually take a look at the Java doc of string, you can see string implements compatible interface. Okay, so same thing with the date class and same thing with the integer class. So natural order of the string class is defined in the implementation of this compatible interface. All right, so moving forward, let's talk about the list interface and implementations. So list interface provides ordered collection, and sometimes it's called a sequence. Now, as opposed to set, which does not allow duplicate elements, list interface allows duplicate elements. So that's a big difference. Now, another difference is that the list object has index. The user of a list generally has a precise control over where in the list each element is inserted and can access elements by their index, integer index, meaning every element has associated index, meaning position. So these are the additional operations that are supported by list interface over basic collection interface. You can have positional access based on index. Search can be based on index position. Again, iteration and range view. So let's take a look at these additional operations that are being supported by list in a bit more detail. So these are the methods. These are the methods that are supported by list interface that supports positional access. So you can say, I want to get an element with this particular index. I want to have fifth element in the list and things like that. You can remove an element based on index, meaning I want to remove third element. And you can also perform search. So give me the index of a particular object. Because there could be duplication, you can also call last index of. So this is going to return the first, index, meaning index of the first element if there are duplication. Last index of is that if there are multiple elements, it will give you index of last instance of that the element. And so iteration and range view. So these are supported in list interface. Okay, so two implementation classes of list interface they are array list class and linked list class. So array list is considered as a resizable array implementation on the list interface, and it offers a pretty fast and constant time positional access. Each array list instance has a capacity. So the capacity is the size of the array used to store the elements in the list, and of course it is always at least the size of the list size, at least as large as the list size. Typically is bigger than list size. List size is the number of elements, and the capacity of array list is bigger. Now, as I said here, it's resizable array implementation, meaning the size of the capacity of array list get automatically incremented as needed basis. So this is a difference from array class. Array class you have to do manually recreate the array object if the bigger capacity is needed, but array list, the size is going to be automatically incremented. Now you can use ensure capacity method to ensure reasonably good capacity first. If your array list is too small, and then if you are trying to add a lot of elements to it, then the system might have to spend quite a bit of time to incrementally increase the size of it, and that could have a detrimental performance. So you can actually call ensure capacity if you know in advance the reasonable the size of the array list moving forward. Okay, so that's array list. It's probably the most important, most frequently used the class. Now, linked list is a linked list implementation of list interface. Just like the set object, synchronization, same deal. So neither array list or linked list are not synchronized. So you can again use synchronize list method of this utility class to make a synchronized list object. Okay, so we covered set and we covered list. Now let's cover map interface and implementations. So map is basically key value pair. You can actually have collection of key value pair. That is map, and the keys cannot be duplicate. There cannot be duplicate keys. The values, of course, could be the duplicate, but the keys cannot be duplicates. Okay, so two most important methods of map interface is put and get. So put is basically you are adding key value pair. Get is getting the value by providing a key. Okay. Sorted map interface is basically providing order, just like a sorted set interface. Sorted set interface is a child interface of set. Sorted map is a child interface of map, basically providing ordering of keys. So example situations that you want to use sorted map is, for example, dictionaries. So in dictionaries you have words and their definitions, and you want those words to be the keys that need to be in order, alphabetical order. Again, we are using natural order of the string class. And the telephone directory is another example. Telephone directory, you have the list of the people as keys, meaning the names of the people are keys, and then their phone number. Okay, so in this case, again, we are using string class as a keys, and we are using natural order of string class as a way of having sorted order. Okay, so these are implementation classes of map interface. So we have a hash map, we have a tree map, and linked hash map. So this is pretty much the same deal as we talked about set. It's the same kind of concept, but in this case we are dealing with the map interface, map implementation, meaning we are basically talking about key value pair. There is one more interface, queue interface. This is not frequently used, but it's there. So QInterface is a collection used to hold multiple elements prior to processing. So, besides the basic collection operations, Q provides additional insertion, extraction, and inspection operations. Typically, but not necessarily, of the order elements in the first in and first out manner. So, the linked list is in fact implements this Q interface. Okay? So, in that case, it's actually providing first in and first out insertion based. The sequence. And there is another class called the priority queue, is priority queue based in the heap data structure. So this is in fact not that frequently used as set, list, and map interface and implementations. Okay, moving forward, so we cover all Java collection interfaces and the implementation classes. Now there is what is called the collections utility class, and it provides this collections utility class basically lets you do some utility functions. For example, if you want to have the empty object instance of a set, list, or map, then you can actually call empty set or empty list, empty map, and then basically it's the empty set object. Okay. You can also call sort method and shuffle method, and we're going to talk about these things in a bit more detail. So these are utility functions that are supported in collections class: sorting, shuffling, and routine data manipulation, for example, reverse, fill, and things like that, searching, composition, and find the extreme value. So let's take a look at some of these examples. Sorting is probably the most frequently used function here. Again, it reorders a list so that elements are in ascending order according to ordering relationship. So these ordering relationships are typically based on elements natural order. Okay, so as we talk about, string class has natural order based on alphabetical order, and date class has a natural order based on chronological order, and things like that. Or you can provide your own comparator implementation if you want to have different sorting semantics. Okay, so we'll see an example code in a few seconds. Okay, so just going over the concept of natural ordering again. So type of an element in the list already implements compatible interface. As long as it has implementation of compatible interface, we consider that class to have a natural ordering. Okay, so we talk about string is based on alphabetical order, date is based on chronological order, and things like that. And as we have talked about before, both the string and date classes have implementation of, they already implement compatible interface. Okay, so we consider those classes to have a natural ordering. Now, if you are trying to sort the list, and if that particular class does not have natural ordering, meaning it doesn't implement compatible, then when you call sort method of the list object, it will have class cast exception. Okay, so this is sorting by natural order of a list. So here we have the array of string, right? And then we are going to create from the array, we are going to create the list object, and then we call sort method passing the list object. Now, since string already have natural ordering, it will order based on alphabetical order. Now, so that's a sorting based on natural order. Now you can implement your own comparator interface in your class, and you are basically specifying different ordering semantics. Okay, so let's see the code. So here we have array list with these the elements, and then I create my own comparator object. Okay, so this is a static class, static method of my own my comparators class, and I'm basically passing comparator object along with my the collection object when I call sort method. Okay, so it's going to use this comparator object and the logic that I specified, comparison logic I specified in this comparator will be used to sort. Shuffling is the opposite of sort. So it destroys any trace of order that may have been present in the list. So if you are trying to build an application that, for example, game of cars application, and if you need to shuffle, then you can use this shuffle method of this collection utility class. Or if you are trying to generate a test cases, and again you can use this shuffle method. Data manipulation, so you can reverse, you can fill, you can copy, and you can swap, and you can add all. So these are all utility functions that are provided by the collections utility class. Searching, you can call binary search of your collection object, and then you specify what you're trying to search, and it will give you a position. Okay. Miscellaneous functions, like a frequency returns a number of elements in the specified collection. So I like to find out how many times my element is in my collection object. Disjoint returns true if these two collection objects have no elements in common. So that returns true. Abstract classes, that abstract classes for collection, set, list, and sequential list, and map, and things like that. So these are abstract classes that are provided if you need to implement your own implementation classes of set, list, and things like that. In general, you don't have to create your custom implementations. In general, the implementations that are provided by the JDK should provide enough functionality for, most of the applications we write. Okay, so it's mainly for aiding custom implementations, which rarely happens. All right, so that's the end of the presentation. Now we are going to go into take a look at the hands-on lab. Okay, so let's take a look at the hands-on lab. So exercise 1 is for set interface and implementation classes. So we are going to just take a look at the sample code. So here we created hash set, and we add 1, 2, 3, 4, 5, and then we print them out. And then we are trying to add 1 again, and this should return false because set implementation, hash set, should prevent duplication. So whenever you add, and if it has been successful, it will return true. So for these 5 cases, we should have 5 trues, just like this. And when you print it out, we have 1, 2, 5, 3, and 4. Okay. And these are random order because hash set doesn't provide any ordering. And now when you try to add 1 again here, it should return false. So that's what you got, false here, because we already have 1. And so when we print them out, yeah, so this is just print them out again. Pretty straightforward code. So this is a case that we can actually use hash set or any set implementation to detect whether there is a duplication or not. So, we have an array object called a name, and then we are going to add into a hash set. So when it is added successfully, because there is no duplication, it will return true. If it returns false, that means there is a duplication. So we should have a duplication. When this item is added, we should have false. Okay. So in this case, we are going to see duplication detected. Duplicate detected is the second string, and then we have 3 elements that are unique in the hash set. Okay, pretty straightforward. So here we have uniques and dupes, and basically we are collecting uniques and we are collecting dupes as the hash set. Okay, so we have these hash set that contains the items that are unique, and this is the hash set that that has a duplication. Pretty straightforward code. Okay, tree set provides order based on natural order, right? So here we created tree set object, and we create a second tree set object, and then we are going to just display, and we should have order. So this is the type of string, so it will use natural order of the string class, and here these are elements in types of integer, so it will use integers. Integer class is natural order, so the it will be 4, 1, 3, and 2, and here the numbers should be natural ordered based on its values 1, 2, 3, 4. Okay, the next one is linked hash set. So linked hash set is providing order based on insertion. So we have again the same thing, same code, but using different set implementation class, in this case linked hash set. So it will be basically insertion order 1, 2, 3, 4, and then 2 is not going to be added because that's in the duplication. Here 3, the second 3 should not be added because that's the duplication. So it should have 1, 2, 3, 4, 1, 2, 3, 4, and 2, 1, 3 as an order. Okay. Set and polymorphism. So set is an interface, and that is used as reference type, right? And depending on what object instance it is pointing to, different behavior is being used. So that's polymorphic behavior. So that's basically, I think, what we have seen in the presentation. So here we are creating hash set from the same array object. And here we create a tree set, and we create the linked hash set. Okay, and these are string values, not integer values. Okay, so when we use the hash set, the order is random here, and when we use tree set, we are okay. So I think we actually converted into the integer. So this is tree set based on the values of the integer. And this is a linked set. This is the insertion order. Okay, so moving forward, now we are going to take a look at the list and list implementation. It works pretty much the same. So here we created array list object with the initial capacity of 2. And then we are adding 3 items, and you can tell the array list will be automatically increasing its size. So we added all UO and new string X, and then we are adding integer. Okay, and we are actually basing, this is the index location, and this is the item that we are adding it. Okay, so every time you add, we actually display the size of it. So first time the size is 0. The capacity is 2, but the size is 0, meaning there is no element added. Now we have added 5 elements, so the size should be 5. Now we are removing 1 element, so at that point size should be 4. Okay, and we can also see whether that list collection object, array list collection object, contains an element. So here, whether it contains X or not, whether it contains P or not. Okay. And here we created iterator, list iterator, and then we are basically using hasNext and next method. And here we created array object by calling toArray method. So those are relatively straightforward. So this is another example of array list. So we created new array list, and then we are basically adding the each yeah, so this is actually a deck of cards. Okay, so the next sample application is creating poker hands. So the example scenario that we are using here is that we want to create 3 hands, meaning for each 3 player, we'd like to hand out 4 random cards from that deck of cards. So basically, if you run the application, so let me just run the application. So that is linked list deal. So this application, and run the application. So basically, we start from deck size 52 cards, and for player number 1, we generate a jack of hearts and 5 of diamonds and 3 of diamonds and king of diamonds, 4 cards. And for player number 2, we generate 4 cards from the remaining cards, and then this is what third player get as a hand, as a cards of poker. Okay, so let's take a look at the code. So first of all, we have set of suite, and then we have set of rank. Okay, so we have 52 cards, and we basically have array list object, and we are just adding these cards. So we have a 52 after this, and then we call shuffle method to shuffle the deck. Okay. And then for each number of a player, in this case we have 3 players, we are going to call deal hand method, which returns a list object that contains 4 cards. So here what we do is we get the deck size first. The first is 52, that's what we actually print out here. And then we call sublist method of the array list object. And this is basically the last 4 cards. And what's important of sublist method is that it's not really returning a separate list object. Instead, it provides a view. So in order to create a new list object, you have to actually pass that view to create a new array list object. And then we are going to actually pass it back to it is going to return that array list object. Now you can now we have to remove those 4 cards that were were handed. So we have to call remove all method of this hand object. Okay, or you can use this method. So here this is a little bit kind of strange, right? So you call hand view.clear. What it means is that we are removing those 4 cards. So again, remember, this hand view is just a view. It's not really a array list object. It's basically what it's saying is that I'd like to remove this set of cards in this view from the original list. So that's what this means, and that's actually the same code with this. Okay. In terms of number of players and number of cards for each player, these are the arguments that are passed to the sample application. So this is what you see. Okay, so the next one is using linked list. So we created linked list here, and basically linked list you can specify the position using index. So you can also call add first method, add last method, remove first, remove last, and here you are removing first instance of integer 1 object, and here you can find out the index of an element. Here you are removing third object in the linked list. So this one is starting from 0 as an index, so this is removing third object, third element from the linked list. Here we are setting the second element in the list to, in this case, 1. Okay. You can clone the list object, and you can just build and run the application. Okay, moving forward, exercise 3 is for map interface and its classes, map collection. So it's basically a key value pair collection. So let's take a look at the code. So here we created hash map, and then we initialize the frequency of testing data. So this is the testing data, and what we want to do is we want to find out how many instances of each item of this one has. So eventually when you run the application, what we want to have is key value pair of this. So in this case, Shin is key, Sang is key, Passion is key, and Boston is key, and these are the values. So basically we like to determine how many times a particular key in this case has occurred. Okay? So the code is pretty much pretty simple. So here we are going through this array object of this name array object, and then we find out, we try to get it using the key, okay, for each name, and if it is null, that means it has not been there before. So this is, we are just setting it as 1, and if it has been before, then we are just incrementing it. Okay, so pretty straightforward code. Here we are using tree map object. By the way, here this is a random order. So when you're using hash map, there is no order involved. Now, if you're using tree map, we are actually using the same code, but we just use a tree map. In this case, order is based on natural order of the key. So in this case, the key is a string type, right? So the order is going to be like this: Boston, Passion, Sang, and Shin. So you can see these are in the order of the key, and in this case natural order of the string class, so alphabetical order. The next one is linked hash map, and again we are using the same code, and here is going to be in the order of insertion. So it's going to be Sang, Shin, Boston, Passion. Okay. The last example is, again, we are using the same thing, but this time we are passing different map object. One is the hash map, the other one is the tree map, the third one is linked hash map, and this code is pretty much the same, and we are using map as a type. So this one is pointing to a different object instances, one for hash map instance, the other one tree map, and third one is a linked hash map, and through the polymorphic behavior, it will actually return the object in different order. So you can see this is random order, and tree map is providing order based on key classes natural order, and this is for insertion order. All right, moving forward, exercise 4 is iterator. So here we are using for loop. So we get the iterator object, and then we can use has next and then called next. So when you run the application, we are basically displaying the names of the month that contains all. Okay, so the code is pretty simple. So in the main code, we call date format symbols. We actually use date format symbols class to have a list of the month. Okay, and then we pass the list of the month as an array, and then in this code we are performing iteration, and we just filter out only the months that whose name has an all. Okay. All right, the next one is showing how to use remove method. So the remove, when you call the remove, is basically removing an item, an element from the original list, from the original the collection object. Okay, so in this sample application we have this array list of 1 2 3 4 5. Okay, and so the first time we are just displaying it, so we'll see 1 2 3 4 5. Next, what we do is that if it is number 2, then we are going to just remove it from the list. Okay, and then we display the list again. So the second time when you display the list, you see that number 2 is missing because we removed that number 2 from the original list. Okay, exercise 5 is sorting, searching, shuffling, and data manipulation. So this is sorting. So here, so when you call the sort, the sorting is based on natural order of the collection object. So in this case is a string, and here is integer. So the sorting will be based on, in this case, alphabetical order, because a natural order of the string class is alphabetical order. In this case is integer, so natural order of integer is the numeric value. So this is what you're going to see. Okay, so 5.2 is an example where you are using the comparator implementation, interface in its implementation, rather than using natural order. So here we are using comparator object. We create the comparator object by calling string comparator method of my comparison class, and then we pass the comparator object. And so here we have the string comparator, integer comparator, and we have date comparator. So we create this comparator object ourselves. If you take a look at this code, this is actually reflecting the natural order of the string and date and integer, but you can actually have a different semantical behavior in terms of its comparison. So we have a string comparator and integer comparator, and then we have a date comparator. Okay, so let's see. And shuffling the list. So basically, shuffle is pretty straightforward. And data manipulation is we actually reverse it. And binary searching, this is the sample code that we have seen in the presentation. Okay, so that's the end of the presentation. Thank you very much.